everybody, this is Arif. Today we will solve some problems on inverse trigonometric functions. There are actually 3 of them. Before we start, I would like to remind you that on my channel now there are different playlists. So please go over the playlist that I've just created and you may find really interesting stuff that you may like. So today we will try to show that, first of all, arccotangent x is equal to arctangent 1 over x when x is larger than 0. Okay, let's show that. First, arccotangent x, so let's call it alpha, and let's call arctangent 1 over x beta. Okay, this is really good. So this actually tells me that tangent beta should be equal to 1 over x. And this tells me that cotangent alpha is equal to x. Okay, so we have one condition here. X must be larger than 0. So if x is larger than 0, what are the range of arccotangent and arctangent functions? Okay, so in other words, alpha and beta. So alpha and beta are both less than pi over 2 and larger than 0. This is good. So for each of these we can actually draw a right triangle. So when I set alpha here, so what is cotangent alpha? X over 1. So x over 1. So if I plot another right triangle, beta, so what is tangent beta? 1 over x. So as you see, alpha must be equal to beta. So this actually shows that arccotangent x is equal to arctangent 1 over x when x is larger than 0. So we already proved that. So let's move on to the next one. Okay, we already showed that arccotangent x is equal to arctangent 1 over x when x is larger than 0. So now let's see what happens when x is less than 0. This is our second question. So x is less than 0. Okay, x is negative. So let's look at arccotangent function first. Arccotangent function is going to take values less than pi and pi over 2, right? Okay. How about arctangent function? Arctangent 1 over x. So this is going to be less than 0 and it's going to be minus pi over 2. Okay? So we assumed x is less than 0 here. Okay. So at this point what I can say is arccotangent x can be an angle like pi minus alpha. So where alpha is in between 0 and pi over 2. It's an acute angle. Acute angle. Acute angle, okay. So arctangent 1 over x will be equal to, let's say, minus beta. Okay? Because x is less than 0, so it's going to be a negative number. So arctangent is going to be in between minus pi over 2 and 0, like we said here. So beta is an angle between 0 and pi over 2. Okay? It's also an acute angle. Okay, so if you want to write arccotangent x minus arctangent 1 over x, what we have is arccotangent x is pi minus alpha. There's another minus here, minus arctangent 1 over x is minus beta, so this becomes beta. Okay, this is good. So this is nothing but pi minus alpha minus beta. Okay, very good. But alpha and beta are acute angles, okay? So then what we have is actually cotangent alpha must be equal to absolute value of x. Okay, and tangent beta must be equal to 1 over absolute value of x. Because alpha and beta are acute angles, cotangent alpha must be positive, tangent beta must be positive. So when I plot the right triangles for them, so if I put alpha here, okay, cotangent alpha is this, okay, but tangent beta is going to be equal to 1 over absolute value of x. So beta, tangent beta is 1 over absolute value of x. So as we see here, alpha must be equal to beta. So this term goes away. So this is simply equal to pi. So then our cotangent x becomes equal to pi plus arctangent 1 over x. So we also proved the second one. Let's move on. So now we want to solve the third question. So it says for all real values for x, arccotangent x plus arctangent x is equal to pi over 2. So we want to show that. Before we move on, I want you to remember the arccotangent and arctangent functions. Okay. So let's plot arctangent x as a function of x. Okay. So you may remember it is an increasing function and it has two asymptotes, right? So this is pi over 2 minus pi over 2. How about our cotangent function? Cotangent is a function of x, so it has an asymptote at pi. So this is pi, so it goes like that, crosses the x-axis, goes to 0. So here is pi over 2. So x is equal to 0, x is equal to 0. Okay, before we solve this, let's look at some of the limits. Okay, so the limit when x goes to infinity, what is arccotangent x plus arctangent x? Okay, so this limit is equal to, so when x goes to infinity, arctangent x goes to pi over 2 plus arccotangent x goes to 0. So as you see, this limit gives me pi over 2. This is good. So how about x is equal to 0? So what is arccotangent 0 plus arctangent 0? Well, arccotangent 0 is pi over 2. Arctangent 0 is equal to 0. So this is simply equal to pi over 2. This is also good. So similar to this limit, when x goes to negative infinity, okay, arctangent goes to minus pi over 2, but arccotangent goes to pi. So pi minus pi over 2 also gives me pi over 2. So these limits kind of work out well, but now we want to show for all real values of x, okay, we want to show that arccotangent x plus arctangent x is equal to pi over 2. So let's show that. Okay, we already showed some of the limits, and we also looked at x is equal to 0 case. And now we will look at this sum when x is larger than 0. Okay, so if this is the case, we can call this an angle alpha. This is beta. So as we have discussed before, alpha and beta are both in these regions. Okay, so now cotangent alpha is equal to x and tangent beta is equal to x. So if you plot a right triangle, cotangent alpha is equal to x. So this is x and 1. This is alpha. Tangent beta is equal to x. So this has to be beta. So then alpha plus beta must be equal to pi over 2, right? So this is easy to show that using the interior angles of the right triangle. Okay, so now let's look at the other case. When x is less than 0, what do we have? Okay, in this case, again we can call this, let's say, minus beta. We can call this pi minus alpha, right? So this sum becomes pi minus alpha plus beta. Okay, very good. So we know that cotangent alpha, so alpha and beta are acute angles again, right? So cotangent alpha is equal to absolute value of x, and tangent beta is equal to absolute value of x. Okay, so if we plot the right triangle, we actually get the same thing, right? So this is alpha, so this is x and 1, and this is going to be beta. Tangent beta is x over 1. So as you see, alpha plus beta is again pi over 2. So pi minus pi over 2 is equal to pi over 2. So we also prove this. Okay. We also show that arccotangent x plus arctangent x is equal to pi over 2 for all real values of x. So next step, I will do something a little bit extra here. So arccotangent x plus arctangent x is equal to pi over 2. So if, let's say, x is larger than 0, okay, I can write arccotangent x as arctangent 1 over x. Arctangent 1 over x. So plus, we have arctangent x, which is equal to pi over 2. Okay. So arctangent x can be written as pi over 2 minus arctangent 1 over x. So this is one of the relations that we will be using when we discuss power series in the future, okay? So I'll make a reference when the time comes, okay? So I just want to show you that arctangent x is equal to pi over 2 minus arctangent 1 over x when x is larger than 0. So in some cases we may want to write the function in terms of 1 over x but not x. So this is one of the relations that we use a lot in those cases. Okay, so I hope you liked the video. I look forward to seeing you in other videos soon. Take care and have a STEM-tastic day. Bye.